Good morning, all of you. I will start in 2 minutes. I will wait for 2 minutes and I will start this. I will explain what is equal area axis for this type of section.
Sir, please unmute.
Actually, see, I am just drawing the figure. I have not started. See, now you can see this one. What is meant by equal area axis? See, when you design these gantry girders, you need to calculate equal area axis also in addition to neutral axis. Now, what is meant by equal area axis, or in case of, for example, in case of this is neutral axis, and in case of a rectangle or a circular section or I section with both flanges are having same dimensions. Flanges are having same dimensions. They will coincide. So what exactly is your equal area axis? So if I can divide the given figure into two equal parts. Equal parts means area should be same at the top as well as at the bottom. So in case of a rectangular section or a square section, what will happen is neutral axis and equal area axis are coinciding because see, above the neutral axis this much is the area. So area above and below axis is same. For example, if this is, let us say, 20 and this is, let us say, total height is 80. Now if I tell you, you give me a horizontal line which is going to divide, which will divide this into equal areas. Now what you will do, this is 20 into 40, this is also 20 into 40 now. Unshaded and shaded areas are same. But when the section is like this, the equal area axis and neutral axis will not coincide. They will not coincide because what happens is neutral axis may be somewhere here. Okay. Equal area axis may be slightly below here or maybe above also. Only thing is that they will not coincide because the line which is going to divide. For example, if I say that this one is equal area axis, in case of T section, you observe here. If I call this as this black dotted line as equal area axis, what it means here is area below this line and above this line should be same. That is A by 2. So if area is A, if you calculate this much area, if you calculate, it should be A by 2. If I give you the total area, you should find this height. You find this height in such a way that you decide this height in such a way that area of this rectangle is equal to area of these two above this line. Means I'll call it as, let us say, YP. This is YP, this is Y bar. They will not coincide in case of unsymmetrical sections. The section which is symmetrical about only Y axis here, in this case also they will not coincide. Here also they may coincide provided the dimensions are like that, which is very rare case. So this is Y bar is the position of neutral axis, YP is the position, whatever is the YP value, depending upon YP value, the area of shaded portion and unshaded part are same, A by 2. Okay, if total area is A, and if I ask you to calculate this one, okay, let us say this is whatever BW or whatever it is, maybe 200, something like that. And if you calculate BW into YP should be equal to A by 2. It should be equal to A by 2. Here they are coinciding. Okay. So how to find out in case of a big profile in steel structures, how to do it? This is all first year it is. In steel structures, how you are going to do this one? I'll show you, observe. I'll take one problem here. Okay, I'll take this profile. This profile is like this. I'll try to tell you what is this profile first. You don't worry about the problem and all. The problem comes later. This is just a part of the solution. It is. Observe this one here. So I'm going to. I have selected one profile here. See this. This profile is one channel section and one eye section. They are placed like this. They are placed like this. You'll come to know later on. Now you see this one. Locate the centroid and equal area axis for the profile shown below. Your Gantry Girder profile looks very similar to this. What they have given here is, you have to find out a line YP. I have calculated 510.23. You have to calculate this height such that above this line A by 2, below this line A by 2, total area. How to get this YP as well as Y bar. Y bar I will show you later on. Y bar I have calculated from the top. YP I have calculated from the bottom. So you can understand this one here. Locate the centroid and equal area axis, NA as well as EA, for the profile shown below. Now this one is a channel section ISMC 300 at 0.35 kilonewton per meter. It means every 1 meter length of this particular ISMC, the weight is 0.35 kilonewton. So once they have given this one, means everything will be there in the steel table. It's related to this particular channel section. Now you can see this one here. And I section is also connected like the profile is created in this way. Now I section is what? ISWB 600 at 1.31 kN meter. Once you check this steel table, you are going to get all the properties of this particular I section in the steel table. Usually I have solved this one. That is why you are able to see all other values. It means you have to calculate these two values, 517.6 and all that. This is directly visible. Directly looking at the figure, I will get it. I got it looking at the figure only. This calculation is YP, equal area axis, YP. For what value of YP? For what value of YP, area on either side of this line are equal. That is A by 2. Now observe this one here. So see, using these two sections, you have to tabulate the values: property, I section, channel section. So it is your job. You have to do this because you already know that ISMC 300 is mentioned, ISWB 600 is mentioned. You have to open the steel table, then you have to tabulate these values like this. So property, notation, I section, channel section. So area is denoted by A here. I have written two times, but it is only once you should write A. Area of the I section. You can see this is the I section here. Total area is given. This is all taken from the steel tables. So 17038 mm square. Then flange thickness is 21.3. See, this 21.3 is here. I'll just show you everything here. Now first is area, is total area of the I section, that is 17038. Then flange thickness, you can see this is the flange thickness. I think you are able to see this one, no? It is here, flange thickness is here. Okay. Next, web thickness 11.2. You can see this is 11.2 web thickness, web of the I section. You go on checking I section only here. Flange width is 250. So this is 250 here, width of the flange. Then moment of inertia Iz as well as Iy is given. I have not written here. For this calculation, it is not required. For the entire solution of Gantry Girder, Iy is also required. But here, not required. Mi is equal to Iz, I have written. So this much is the value. Okay. This is the value of Iz. Depth of the section H is 600 mm. Where is this one? Depth end to end. See this. From this end to this end. I think you can follow all this. This total end to end I section. This is 600. That is given in the that table. Okay. Then finally, radius of root is R1. Somewhere here radius is there. Radius of the root we call it as. It is not perfectly. There is a curve here. For that curve, radius they have given 17 mm. So this is about your I section. Same thing is given for channel section 4564. Area of this channel is 4564. Next, flange thickness. Now these are the flanges here. It is inverted like this. Okay. So you should not get confused here. So this is all flange. So 13.6 is the flange thickness. I have written it like this. Flange thickness 13.6. Web thickness is 7.6. So this is 7.6. You can see this one. This one is okay. This one is 7.6. I think you can follow this because I think you studied steel structures during Corona only. RCC that time there was no Corona, I think. So anyway, just observe here. This is 7.6. So the profile they have given, profile is fixed like this only, it is kept. You have to just note down the properties. Then you can see the moment of inertia 6362.6 into 10 raised to 4. Depth of the section is 600. Depth of the channel is 300. Where is that one? This one. Here it is horizontal distance. This is depth. So 300 it is. So like this you have to note down all these values. Now how to find out the value of YP so that area below this line and area above this line is equal to A by 2, total area by 2. So I'll start with A by 2 only first. Any questions are there, you can ask here. I'll go to the next page. Now I'll show you how it is to be done. The total area is area of I section plus area of channel section 10,801. I think I just calculate it. Somebody can use the calculator. The values I'll show it here once again. 17038 plus 4564. Just calculate it, because I'm going to explain only this page now. After this, I'll stop it. Only one page is this page. Once it is done, I'm going to stop it. Just give me this total area. Is it 10801?
Yes, sir.
No, sir.
21602.
No, sir. 21602.
21602.
Yes. Correct. Divided by 2 is 10801. Here it is correct. Calculation is correct. Only this at this place, here I committed a mistake here. Here I committed a mistake. Rest all is correct. This is a total area by 2 is just calculated. You just calculate these two, divide it by 2.
Yes, sir. Correct. That is.
This is correct. It means while writing a mistake was committed. So this is correct now. There is no problem here. Means all calculations will be okay.
Sir.
Now observe here. Total area is area of I section plus area of channel section. You write that value. I'll just note it later on. Finally, see how to get YP now. So what I will do is I will just do like this. I'll just say this is YP to start with. I'll call this as YP. I don't know the value right now. Just I'll call this as YP. Let us say the equal area axis is located at a distance of YP from the bottom line of the flange. Bottom flange. So from bottom of this one flange line, this one, let us say, let me call it as YP. Right now, I don't know it. Okay. Then what I will do is, in this zone, whatever is coming, I have to calculate that area. Now what I will do, observe here. I will do like this. So let us say this is YP here. It means you can see this shaded portion now. This one. This just below this equal axis, this whatever blue color shaded area is there, how much it should be? It should be how much? It should be A by 2, correct? It has to be A by 2, isn't it? Because this line should divide the total area into two parts. It means if I say that this is the equal area axis line, below whatever portion is there, that must be equal to the above whatever is there in terms of areas. Exactly, it should divide the area into two parts. So what I will do is I'll calculate this area here, this plus this, two rectangles are there, and I'll equate it to A by 2. I'm going to equate it to 10,801 because I know that this is area by 2. So what it means here is, I will write down the area here, area of this shaded portion, and I'll equate it to 10,801. In that one, YP will be calculated. That is what I have done. Observe this. Area of, okay, just two terms are there. There are two terms. One is this. This term is related to, just observe this, 250 into 21.3, one rectangle. First term is related to this one. Second term is related to the remaining part of the shaded area. In this way, you have to calculate it. Now see this one. You can observe this here. First term is 250 into 21.3. Okay. Second is YP minus 21.3 into 11.2. What is the second term? Two terms will be there. 250 into 21.3. This area is over plus the remaining portion. Remaining is what? Remaining is YP minus 21.3. How much is this height? You look at this one. How much is this height now? Because second rectangle is this. How much is this height? First is this one, 250 into 21.3. Second is, how much is this height? YP minus 21.3, because YP starts from bottom line. So this red arrow is there. This is into 11.2 it is. So the rectangle, this rectangle is, what is the area of this rectangle? Dimensions. This is yp minus 21.3 is this height into 11.2. That is what I have written here. Okay. Yp minus 21.3. It is height of the rectangle into width of the rectangle, which is 11.2. So these two together should be equal to area by 2. Half of the area it should give. So 10,801. So now yp can be separated here. That is, this multiplication is done. 532, 5325. Again, 11.2 is taken inside. This is simplification. 11.2 into 21.3. This is this one equal to this. Finally, yp is simplified. So 510.23. 510.23. So when you draw this, when you get this one, whether one important observation here is when you solve the problem. One important observation that you should check here is whether it has gone like this or what. Whether the height has gone, it will happen sometimes. This will happen. Whether it is here or what, that also you should check. Whether it is here means a small part of this one channel section has come here. See, below the equal area axis line, a small portion on either side. In some problems it will happen actually. In some problems it will be below this line, below somewhere. In this case it is below. Let us see whether it is below or what. How to say that this has not happened? How to say that in this case? So how to do that? So you know that this is 510.23 now. From bottom it is 510.23. Then you should get this value now. You should get this height. What is that one? You should get this height. What is this height? Exactly touching this line. You can see this. How much is this? This has to be more now. If this calculation is more, then only I can say it is below. This has to be more. How to decide this one? Total you calculate in that one minus flange width, flange of the channel section you have to calculate. I'll show that one. What I'm trying to tell you is sometimes equal area axis goes like this. That has to be clearly checked. Now, even in this problem, it is 510.23. Now I'll calculate this one. If this is less means it has gone inside now. So how much is this? How do you calculate it? For that one, I'll go back to this figure. In one of the problems that I have solved, this has happened. A small portion of a channel has come, including the area of the small rectangles this side and this side, plus the entire this part, that has become a by 2. That is why now you can see this. How I have done this one, how I checked it. First 510.23 was calculated, then I calculated this distance from the bottom to this bottom. How it is done? Total is 607.6 total. Total overall depth of the entire profile. See this entire profile is it is 607.6. Now observe here how it is. Depth of I section is 600 plus add this thickness, which is 7.6. So total is 607.6. In that one you subtract. In that one you subtract this height. You remove this height. You remove this. Total 607.6 minus 90. You will reach this height. This height. So which is calculated as 517.6. Slightly more it is. It is 510, it is 517. Roughly I'm telling. Roughly. This is 510, this is 517. There is a gap of 7 mm, maybe less than that, because of 0.6 and 0.23. Maybe it is less. But you can see this one. This equal area axis line has not gone inside the channel section in this problem. If it goes inside, you should consider small rectangle this side, small rectangle this side. That adding that one and this area, remaining area only, it will be a by 2. So this is how you can find out equal area axis in case of a standard profile. This is a standard profile for Gantry girder. You'll come to know later. Let us imagine like this. Let us understand two sections are given, channel and eye section. You are supposed to find out equal area axis. So any questions in this one? Any doubts? How to find out equal area axis using a profile given in the problem. You can see the profile is given as well as the sections are given. ISMC and ISWB sections are given. So once you understand this one, you understood a small part of the gantry girder design. It means you are able to find out equal area axis, where it is used. In calculation of plastic modulus, it is used. That I'll take that one later on, because today suddenly he was he was on leave. So I thought of explaining this small portion so that later on I can go faster. When I start actual gantry girder, when I reach this step, I'll be going fast there. So any questions are there here? How to calculate the equal area axis? If any doubt is there, you ask. So what is done here is mark the line, call it as YP. Whatever below that line, two portions will come, two rectangles will be there. Sum of those two rectangles is equal to total area by 2, because it should give me half of the area. Now what it means here is 10,801. If you calculate after this finding the dimension 510, now if you calculate, it should be 10,000 that, and if you calculate the remaining part also separately, that should also give the same number. Then only it is equal area axis. So next is how to find centroid. Imagine if this problem is given in the first year, what will happen? If I give this problem to the first year. So somebody was asking when I was engaging this class, sir, what is the use of centroid and all, moment of inertia, what is the use of that? Now see, it is actually we are designing a gantry girder where we need this. We cannot say that how it is useful or what. It is now at 7th semester level and making use of, for actual design of a gantry girder, and making use of centroid and moment of inertia values. So for a first year students, we cannot set this type of a problem there. Now let us go to the next step here. After this, I'll stop it. I'll take attendance on continuum of software. Right now, 79 students are there, including me, means 78 are there. I'll take the attendance and I'll stop it. Time is almost ending. Means for attendance time is there now. See, now how do you find centroidal axis, where it is? Now here what I have done to avoid calculation complications. See, in the textbook they have done from the top, they have calculated YP. It becomes more complicated. If you choose YP here, only two rectangles will come. If you take top as a reference line, so many confusions, so many rectangles will come now. This rectangle, this one, this one, this one. In textbook they have done like that. I thought of using the bottom, from the bottom YP should be measured so that you have to deal with only two rectangles. Now observe here. Now what I am doing is I am going to find out Y bar. But while calculating Y bar, purposely I am going to choose the top one. Why it is, you can see this one. Why this is done? It makes the problem easier actually. You may feel that if I go from the bottom only, if I use Y bar, it will be easy. You try that. You try that. This is easier than that. Observe this. Any questions are there, you can ask here. Let us calculate Y bar. Now how the Y bar is, it is nothing but sigma AY by sigma A. A1 Y1 plus A1 Y2 divided by A1 plus A2, like that. Now observe here, what I have done here is, I'm going to see, I'm going to locate a Y bar from the top. Y bar from the top, I'm going to locate it. It is very fast actually. It takes just 5 minutes to find out Y bar, because you know everything there, you know all the calculations. You see, for a first year student, it becomes very complicated. But for a person who is having steel tables, it is very easy actually. See this one. Let us say y bar is measured from the top. Let us see what will happen. Just see this one. Simple formula is there. How to find out centroid of this profile? See this. A1 y1 plus A2 y2 by A1 plus A2. Okay. Now how it is done? In this equation, if you look at this equation, A1 17038, it refers to I section. Y1 refers to I section. A2 is total area of channel section, and Y2 is of channel section divided by area of total area of channel and I sections. 2 minutes it will take if you are smart enough. Now what I have done is I have separated these two for your understanding. See, actually I want y bar means along this line I should fix y bar line along this line. So my intention is here, see this. My intention is like this. I want to locate y bar from this line, how far it is in the combined figure. In the combined figure, I want to locate it like this. Somewhere here, I think it is centroid is lying, and yp and y bar cannot be same. You'll come to know that one here. So my job is to locate for the entire section. Purposely, I have exploded these two, separated these two. Now observe this. This figure is A1, Y1. For I section, it is A1, Y1. First term refers to this diagram. So what is A1? What is A1? Area of the entire section. Now what is Y1? Y1 is centroid of this I section from this top line, because top line is the reference line here. Axis of reference is top line. So what will happen? It is up to this, it is, as you know, 600 by 2. Total is 600. Total height of this one is 600. So this is, see, this one is 300 because total is 600. Total depth is of I section is 600. So this is 300, but the reference line is here. So I should add thickness of this channel section. So 300 plus 7.6. So Y1 is 300 plus 7.6. That is what I have written here. You can see this. Okay. A1, Y1. A1 is total area of I section. Y1 is this way calculated. Second is A2, Y2. This is also simple if you have steel tables with you. You are not going to calculate any rectangle area here. Directly select from steel table. Actually, see Y1 and Y2, you have to actually check it in the diagram, or it is available also. In this case, it is available. Channel section. See this one. A2. A2 is area of the entire channel section, which is written here 4564. Y2. What is this Y2? Y2 is centroid of channel from the line of reference. This is the line of reference. From this line, this is Y2. So Y2 is already there in the steel table. That Y2 should be written here. Okay. So it means you just have to check it, because what is the calculation you have done here? Already 17038 you have seen in the table. 4564 is also there in the steel table. 23.6 is also there in the table. 300 plus 7.6. Only this calculation you are doing. Rest all is available. You have to just check and write down those values. So finally you end up with this number. You end up with this number here. Any questions here? You end up with 247.59. So from the top, it is from this line. From the top line, you go down. How much is that? 247.59. Again, you should try to locate the relative positions of equal area axis and neutral axis line. It means what is the vertical distance between these two lines. That you should be able to calculate. I have not done it here. I have not done it, but you can do it very easily. So from the top line, you come down by 247.59. From the bottom, you go up by 510.23. From that one, you can easily find out whether they are coinciding or whether there is a gap or there is a vertical clearance is there between these two. That is also important here. Okay. So this is how we should calculate for a given profile. This is a part of Gantry Girder which will be taken up later actually. But that time I can save time here because this is all geometrical properties calculation. Any questions here? Anybody has any doubt? Because still 10 minutes are there. I can take the attendance on continue here on the software only. So any questions are there? How to find this one? I'm going to say I'm going to upload this one later. You can see this one later also. Any questions are there? You can ask. YP and Y bar explanation I have done. What is the purpose of this equal area axis? You will come to know in the remaining steps of the Gantry Girder solution. There it is required. Right now, I cannot tell you what those steps are not possible right now. Only when I start the problem, I'll explain that one. And today I'll be giving you one assignment problem on plate girder. Solve that one, and so that you can have this one. Otherwise, this is going to take a lot of time. It takes more than 1.5 hours to solve Gantry girder, whereas in a lesser time I can solve a plate girder. So these calculations you should do fast in the examination. All these calculations. So this is your today's remaining